Hello guys, welcome to the next episode in this van conversion series. In today's video we're going to be discussing the LPG installation in our van, and in particular we're going to be looking at the standards of the installation. When I was doing my research I looked at a lot of van build videos and did a lot of research on the internet, and what I found was there's a bit of a grey area with LPG in vehicles. There doesn't seem to be a lot of information online, and there doesn't seem to be a governing body either. You know, when you have gas installed in your house, you have to have a gas safe engineer do the installation and he has to certify it. Well, it doesn't seem to be the same setup for vehicle conversions, or in particular LPG. So there's nothing to stop the home DIYer doing their own installation and then taking their van on holiday without it having to be checked or certified. So what I want to do with this video is I want to go through what are the standards for the installation of an LPG system in your vehicle, and really what are the points that you should be following to make sure that it's safe. I've been onto the BSI's website and I've actually found a copy of the current regulations for the specification and installation of LPG systems into leisure vehicles. So that covers caravans and motorhomes. The standard is EN1949, and this was recently updated in 2013. The standard's not free. I did have to pay for it. It was a considerable amount of money as well, and it came as an electronic download. I've gone through the standard and I've highlighted all of the points that I believe are relative to van conversions, as distinct from caravans or motorhomes. Because this is a van build series, I really want to just pull out the points that I think are relative to what we are doing, you know, as DIY van builders. So what I'm going to do is I'm going to go through the points in order. I'm going to list some of the specific information, give you the detailed facts, and then we'll also have a look at some of the physical objects that we need to install in our van. Let me just reiterate before we get started that these are European standards. So if you're viewing this video from outside Europe, you will need to check your local standards because they may differ from these. And the other thing is, the information that I'm giving you in this video are not my thoughts, they're facts taken directly out of the standard. So when you're writing your comments, please don't shoot the messenger. The first couple of sections of the specification is really a glossary of the terms and defines all of the parts of your installation. And then the first practical part of the standard relates to testing. There are two sides of a gas installation. There's a high pressure side, which is the cylinder and up to the regulator, and then there's a low pressure side, which is after the regulator, from the regulator to all your appliances. The pressure on the cylinder side of the system really changes with temperature, and depending on where your cylinder's stored, that pressure can vary from 1.5 bar at 0 degrees C up to as much as 25 bar at 70 degrees C. I know it's not going to be as hot as that in your van, but this chart that I've put here will give you an idea of the difference in pressures in your cylinder depending on what the ambient temperatures are. So we have high pressure hoses that are rated to 100 bar on the connection from the cylinder to the regulator, and then after the regulator it reduces that pressure right down to 30 millibar, which is very, very tiny. I mean, you can actually hold 30 millibars of pressure back just with your thumb over the end of a hose, so it's quite relatively low pressure. This part of the regulation deals with testing, and what we have to do is, when we've completed the installation in our van, we need to test it, and we need to test it to 5 times working pressure, so that's 150 millibar. And the way we do that is we connect via some hose a little digital manometer. There will be a test point near your regulator, and we need to connect this hose on the system side of the regulator so that we're testing all the pipe work within the van right up to the appliances. You turn all the taps off on your appliances and you open the local isolating valves, because we want to be testing right the way through to the actual appliance. What we'd do is we'd connect this hose onto the plus side of our manometer, and then connect the other side of this hose to the system side on the regulator. You'll see it's got a digital display, And then simply what we can do, I'll assume that this is a closed system, put my thumb over here, and you can see on the display as I pump this up, you'll see the pressure is increasing. And then what you do, you'd pump the system up to 150 millibar, you'd leave it for 5 minutes for the temperature to just even out. You'd then take the starting reading. You'd then wait another 5 minutes and then you take the final reading. And in that time, it cannot have dropped any more than 10 millibar. I mean, personally, I'm going to try and achieve, a starting pressure and an end pressure exactly the same with no loss. Not sure whether that's going to be possible, but we'll see. And in that way, once that test is complete, you know that all the pipework from the regulator right up to your appliances has been tested with 5 times the working pressure. So you can rest assured that that is going to be sound. And then on the high pressure side, on your hoses off your cylinder, it's sufficient to test with leak detection spray. Because we're dealing with a much higher pressure there, it's okay to test it at working pressure. And then what you would do is you would spray all your joints with this leak detection testing fluid, which is very similar to like a fairy liquid. It just bubbles up if there's a leak. You see some little bubbles forming. And the idea is that you should have no leaks within a 30-second period of applying this leak detection. The next part of the regulation, section 5, deals with the cylinder compartment. For caravans and motorhomes, the access to these compartments is made via the outside of the vehicle. There's usually a door cut in the side of the motorhome and you can get to your cylinder cupboard from outside. In van conversions, where it's difficult to make an opening in the side of the vehicle, it's perfectly okay within the current regulations to have a sealed compartment which is accessible from the inside of the vehicle, but there are a couple of restrictions. They've limited the size of cylinders that you can carry, limited to 2 cylinders with a maximum capacity of 16 kilograms each. The gas cylinders must be stored in a sealed compartment, which is sealed from the living space. The other requirement is that there's a 50mm upstand at low level. The sealed door mustn't go right to the floor. The location of the cylinder compartment in your vehicle must not be directly on top of where your exhaust is situated under the van. So it needs to be 250mm outside of a zone around your exhaust. So if you was to imagine an X-ray looking through your floor of your van and you're looking at where your exhaust system runs, if you draw 250mm on the outside of that, then you can't go within that shaded area. There are a couple of diagrams in the specification just to illustrate that. But basically you just got to keep your cylinder away from being sat directly on top of where your exhaust is underneath the vehicle, because the exhaust is really hot and it's going to warm up the floor directly beneath where your cylinder's sitting. In turn, it's going to warm up the cylinder and then that's going to increase the pressure. Within the gas compartment, the cylinder needs to be securely fixed, and it needs to be fixed at high and low level. There's a couple of different ways that you can do that. There are some devices online where they secure to the floor of the van and then you sit your gas bottle on top of it, and that secures the bottom of the cylinder. And then for securing the actual cylinder itself, there are these devices available. It's basically a plastic strap, has a spacer block. This is screwed to the internal side of the cupboard. The strap would go around the bottle and then it's simply just a buckle arrangement just to pull that up nice and secure. There is a requirement in the specification that all straps and methods for securing gas bottles in vehicles, you must be able to undo them without the use of tools. So it's no good using a big Jubilee clip or something like that, because you'd need a spanner to undo it. So with this system you simply undo it just literally by pulling on that buckle. The location of the cylinder within that compartment mustn't hinder the access to the regulator or any of the other components like any isolating valves and so forth, and it also mustn't obscure the dropout vent in the bottom. The gas compartment must be ventilated, and the requirements of the standard state that the ventilation free area must be equivalent to 2% of the floor area of the compartment. This is a typical gas dropout vent. This is a 50mm vent, and this will give you something like 800 square millimeters of free area. what you do is you drill a circular hole through the bottom of the gas compartment, straight through the bottom of your van, and install this vent. LPG is heavier than air, so if you do get a leak, the LPG is going to sink to the bottom of the compartment and then it can vent directly to outside through this dropout vent. The standard does go on to say that if you've got a compartment with internal access, like in a van build, and you've got a cylinder of a small capacity below 7 kilos, then you can get away with one 20mm diameter dropout vent in the bottom of that cylinder compartment. If you need to run electrical cables through your gas compartment, that's okay as long as there's absolutely no joins in that cable, and it must be protected by a conduit or some PVC trunking with no joins in it whatsoever. The openings at either end where it comes in and out of the compartment must also be sealed. Section 6 of the regulations deals with pressure regulation. This is a typical hose for the high pressure side of our system. So this would be connected either from a filling point to the cylinder or from the cylinder to a remote regulator. The regulator can be fitted either directly on top of the cylinder, or it can be fitted within the chamber, bolted to the wall, and you can have a short hose between the bottle and the regulator. There is a maximum distance of that 400mm, it can't be any longer than that, and it must be installed in such a way that there's no stress on the joints. You know, you're not overly flexing this hose and causing those fittings to be under any kind of strain, and then the location of the bottle must be such that you're not obscuring the regulator or any of the shut-off valves. This is a typical regulator. On one side of this you've got high pressure gas which is connected to the cylinder, and on the other side you've got low pressure. As we've seen before, this can be up to about sort of 25 bar if it's really warm in your van, and on this side of the regulator there's a maximum pressure of 30 millibar, and that's the pressure that's then distributed to all your appliances in the van. There's also a maximum flow rate of 1.5 kilograms per hour. Each system should be clearly marked as to the pressure in the system, in this case 30 millibars. All hoses that you use on the cylinder should be clearly marked with their pressure rating, colour coded, and they should be tested for the resistance to LPG. Section 7 deals with the components and the materials of the installation. From the regulator to your appliances, all gas pipework needs to be run in either rigid copper or steel pipework. That can be seam welded steel or stainless steel, but it must be a rigid installation. If your appliances are permanently fitted into your vehicle, i.e. like your fridge is permanently fitted in your kitchen units, or your water heater is bolted to the floor underneath a bench seat for instance, then those appliances need a rigid connection to them. You cannot use flexible hoses for the installation of LPG within your van to permanently fitted appliances. So by far the easiest way of doing that is to get a copper coil, and like I've done, I've run a continuous coil from the gas cylinder at the back of the vehicle right the way through the van, right up to each appliance. So I actually haven't got any fittings other than the fittings on the appliance itself and the fittings in the gas compartment. The only time that you're allowed to use flexible hoses is if you've got a movable appliance. Like for example, if you've got a stowaway cooker, like these little 2-ring burners that you put away in your kitchen cupboard, and then when you want to use it you get it out of the cupboard, put it on the countertop, connect your gas bottle to it and then do your cooking. Those appliances you can still use a flexible hose, but again there's a restriction there. The hose is limited to 750mm. There must be a shut-off valve immediately on the bottle before the hose, so you can isolate the whole of that system, so the hose and the appliance, with a shut-off valve on the bottle. And obviously the hose does have to be to the current LPG standards. The permitted fittings that you can use on gas systems are the ring cutting fittings, very similar to compression fittings where you've got an olive and a compression nut. You can use soldered fittings on copper pipe work. You can use flared fittings where the end of the pipe is flared out into like a bell shape, and the male part of the fitting has a very smooth taper on it, and then again it has a compression nut to make that fit in. They're acceptable. And you can also use just regular threaded fittings like a male thread into a female thread, which is typical for your hoses where they connect onto your gas cylinder. In terms of jointing compounds, you need to use a gas safe PTFE tape on threaded fittings only. Now this is not to be used on any type of compression fittings. So only on male threads you'd wrap a small amount of PTFE around the male thread, and then that would then wind into the female thread. These are typically a tapered thread, so as it winds in it gets harder and harder to turn, and eventually it makes that permanent seal, and the PTFE tape just takes up any little voids or irregularities in that thread. With a compression fitting it's a different thing altogether. The actual joint is made by the olive seating in that little tapered seat there. The olive slips onto the copper pipe, and then what happens is when you do the compression nut up, that squeezes the olive onto the copper pipe, and it also pushes it against that tapered insert there. So the gas tight seal is made at that part there. The gas tight seal is not made on the thread. The thread is purely there to allow you to pull the compression nut up and squeeze that olive. So by applying PTFE tape to that thread, what you're actually doing is preventing the travel of this compression nut. So you're restricting that nut from being tightened up fully, and you might actually cause a leak rather than do any good. If you do get a little bit of a weep on these compression olives, what you can do is use a bit of gas safe jointing compound and wipe a very small smear of that paste around the olive and then remake the joint. But under no circumstances use PTFE tape on any compression fitting. Section 7.5 deals with shut-off valves. At each appliance you must have a local isolation by means of a shut-off valve. You need a means of isolation local to each appliance, so you need a little quarter-turn ball valve clearly labelled that it's gas. It must be very obvious which is the direction for on and which is the direction for off. And again, usually if the handle is in line with the pipework, that means the gas is on, and if the handle is at 90 degrees to the pipework, that means the gas is shut. Section 8 of the regulations deals with the actual installation. Now all the pipework needs to be installed where it's accessible. You cannot install fittings and bends and T's and valves under floors or buried in walls and cupboards or in ceilings where you can't get to them. If you have a potential leak on any of that pipework and it's in an enclosed space, LPG can build up in there and it will cause you a serious problem. The fittings all need to be accessible because for testing purposes you need to be able to check every joint to make sure that it's sound. It needs to be installed in such a way that it's not going to get damaged, so you need to put it in a location where it's not going to get hit. The whole system just needs to be installed so it's not under any undue strain, because while you're driving around, if a joint's under a lot of stress, that's obviously going to be a potential weak spot and that will probably cause a leak. The pipework needs to be clipped to the structure, and there's the maximum distance for clip centres is 500mm. I always go a lot less than that. I've actually put my clips in at 300mm centres just to be a bit on the safe side. I've used a rubber lined clip as well, so that the clip doesn't actually cause any mechanical abrasion on the pipework. You know, if there is some movement on your pipework at all, then that clip is not going to abrade or erode into the pipe. Section 9 of the specification deals with the connection to the appliances. All appliances must be connected with rigid pipework installed free of stress and must have local means of isolation. The only exception to this is if you've got, say, a stowaway gas stove that you need to bring out of a cupboard and put on a counterside to use. In those instances they do allow a flexible hose connection to your cylinder, but there's a limit. It's got to be less than 750mm in length. There needs to be a shut-off valve on the cylinder which isolates the hose and the appliance. The hose obviously needs to be a gas safe hose, needs to be made to the current standards. And you're not allowed to run any of that hose behind cupboards or in areas where it's concealed under floors, etc. Section 10 deals with appliances. In general, appliances that use LPG in your van, like a three-way fridge, a space heater or water heater, must be of the room seal type, What that means is their air for combustion and their exhaust gases are drawn in directly from outside of the vehicle. Now that can be via two separate vents, or it can be via a combined concentric vent. So in the case of a three-way fridge, you normally see those two large vents on the outside of the van. One is for the combustion air coming into the fridge and one is for the exhaust gases going out. Similarly, a lot of space heaters have two vent ducts. Some go through the floor of the van, some are vented out through the side of the van, and they'll have two hoses. Again, one is for the combustion air coming into the heater and one is for the exhaust gases going out. And then in the case of our heater, our Truma Combi, it has a concentric room sealed flue. So the combustion air comes down the outside of that flue and the exhaust gases are emitted down the centre of that flue to a terminal on the outside of the van. So none of those appliances are using combustion air from inside the vehicle, so we don't have to worry about providing additional ventilation inside the van. They're room sealed, and all of the exhaust gases are also being expelled directly to outside. So we're at no risk of any exhaust gases or any ventilation in the van causing us a problem with the burning of that LPG. The regulations state that space heating must be provided by room sealed appliances. So I guess, what they're saying is those little portable heaters that you have freestanding in your van connected to a little gas bottle where they've got a naked flame on the front, they're definitely not a good idea. You need to provide so much ventilation for those to make sure that you're not using all the oxygen in your van and giving off all those nasty gases that really can be fatal. I personally wouldn't entertain one of those heaters in my van. Apart from the fact that you need to provide loads of ventilation, they're a real hazard to health in terms of the gases that they give off, and also a byproduct of the LPG burning, it gives off water. So it's just going to add to the condensation risk in your van, which we're trying to minimise. Section 11 of the specification deals with fluing and flue locations. The flue location from any of your appliances cannot be located closer than 500 ml to any refuelling point. So where you fill up, you've got to have your flue outlet at least 500 ml or more away from that. In addition to that, you cannot put a flue outlet directly underneath an opening window, and it cannot be within 300 ml to one side of an opening window or an opening door. So there's a little diagram in the specification that illustrates where these hatched areas are that you cannot install your flue. And basically the reason for that is to prevent those flue gases from being drawn back into the vehicle. If you've got your flue outlet directly below an opening window, those warm flue gases will rise and they could potentially come straight back into your van. Similarly, if the flue outlet is adjacent to an open window and you've got a bit of wind outside, again that could get blown into your vehicle. So it's a good idea to keep those flue outlets as far away from any opening windows as possible. With regards to the installation of permanently fitted gas cylinders, like my gas flow system for instance, there are a few requirements for those particular cylinders. They have to have an automatic cut-off system when they're being filled. The cylinder mustn't be filled any more than 80%. They must have a level indicator, a manual shut-off valve, they must have a pressure relief valve and an overflow regulator. You must make sure that you shut the manual isolating valve on top of the cylinder when you're refuelling. The tank and its components must be fitted such that you're extracting LPG from the gaseous part of the cylinder, so i.e. the regulator must be fitted on top of the cylinder. Liquid part of the LPG will be in the bottom of the cylinder and then it will be in its gaseous state at the top. You can't lay the cylinder on its side where the connection could be below the level of the liquid, because then you'll be drawing liquid off of the cylinder. The filling point on the outside of the vehicle, very similar to flue arrangements, it cannot be fitted within 500 ml of an opening window or opening door. So obviously while you're filling the van, there could be LPG leaking out from around that filling nozzle connection, and obviously that doesn't want to be drawn into the vehicle either. And again, in terms of the installation on the high pressure and low pressure side of these cylinder systems, you do need to make sure that you do an adequate pressure test on both sides. A warning label must be fitted close to the cylinder to state that all the appliances should be manually isolated before refilling the cylinder. So there we go guys, I hope that's given you some useful information that will make your vehicle a lot safer. I know it's a lot to take in, but out of all of the services that we do on our DIY van build, LPG is by far the most dangerous and it needs to be given the proper respect. All of the items that I've shown you in this video, I'll put links in the description below. If you'd like to purchase any of them yourself, you'll find them there. And I'd really just like to emphasise that you guys must test your systems thoroughly. You know, that testing equipment, that manometer I think was £30, a little bit of plastic tubing, you know, it's small change and it can make a massive difference to the safety of your vehicle. Quite a few years ago I was working for a mechanical services company and the boss's son was spending a weekend living on board a boat at a local marina. He obviously had LPG installed on the boat for cooking and heating. Now he must have had either a malfunction or an LPG leak, because the boat unfortunately exploded and it killed him instantly. It was such a tragic thing to have happened, and it just highlights the fact that these LPG systems need to be given the absolute utmost respect, and you do need to make sure that you've installed it correctly and that you've tested it correctly. If you're going to be living in the vehicle and sleeping in it overnight, you want to make sure that these systems that you're putting in your van are safe. So with that in mind, if you're not comfortable doing the installation yourself or not comfortable with doing the testing, then I would always advise that you get a qualified engineer to do that work for you. I find the best way of finding a qualified LPG engineer is to speak to your local caravan accessories supplier. They will usually have a few guys that they're aware of and that they can put you in touch with. So it just remains for me to say thank you very much for watching. Hope you found that to be useful. If there's anybody else that you know is doing a van conversion that you think would benefit from this information, please do share the video on social media and all of the usual van build forums. I really appreciate all your support, love reading all your comments, and thanks very much for watching. Cheers!